In March of 2026, a Chinese company that American export bans were specifically designed to cripple walked onto a stage in China and unveiled a chip claiming nearly 3 times the performance of a Nvidia processor, still actively selling around the world. Within days, 2 of China's largest tech giants had reportedly placed orders. Within weeks, headlines were asking whether Nvidia's grip on the global AI hardware market, a grip worth trillions of dollars, was finally starting to slip. The company behind the chip is Huawei, a name most Americans still associate with a 2019 blacklisting that was supposed to end its ambitions in advanced semiconductors for good. It didn't. And the story of exactly how Huawei clawed its way back into this conversation, what its new chip can and can't actually do, and whether Nvidia genuinely has anything to worry about, is far more layered than either the panic headlines or the dismissive denials suggest. Stick with me, because by the end of this video, you'll understand exactly what's real, what's exaggerated, and why the answer to Nvidia is scared isn't a simple yes or no. To understand why this moment feels so significant, you need to remember exactly how thoroughly the United States tried to shut this door in the first place. Starting in 2019 and escalating sharply through 2022 and beyond, Washington placed Huawei on a trade blacklist and layered on increasingly aggressive export controls targeting the most advanced chip-making equipment on Earth. Specifically the extreme ultraviolet lithography machines made almost exclusively by the Dutch company ASML, tools considered essential for manufacturing the most cutting-edge processors. The strategy was straightforward. Without access to that equipment, Chinese chipmakers would be stuck years, potentially a decade or more, behind the manufacturing capabilities of companies like Nvidia and TSMC. For a while, that strategy appeared to be working. Huawei's chip production shifted to SMIC, China's largest domestic foundry, which was forced to rely on older deep ultraviolet lithography technology, layering and multi-patterning older manufacturing processes to approximate results that newer machines could achieve more directly. It was slower, less efficient, and significantly more expensive per chip. But it was, crucially, still working. That brings us to March 2026 and Huawei's China Partner Conference, where the company formally unveiled its Ascend 950 PR processor, packaged inside a new accelerator card called the Atlas 350. The headline number Huawei put front and center was direct and aggressive. The company claimed the 950 PR delivers up to 2.87 times the compute performance of Nvidia's H20, a chip that, importantly, is itself a China-specific, deliberately downgraded version of Nvidia's hardware, built to comply with earlier rounds of export restrictions. According to Huawei's own published specifications, the 950 PR delivers 1.56 petaflops of compute at FP4 precision, a low-precision numerical format increasingly used across the AI industry to speed up inference workloads. Backed by 112 gigabytes of a new proprietary memory technology Huawei calls High-BL, its own version of the high-bandwidth memory that's become one of the most contested resources in the entire global chip supply chain, running at 1.4 terabytes per second, with the card drawing 600 watts of power. Independent, Western-verified benchmarks for these figures remain scarce. Huawei has not submitted the 950 PR to ML Commons, the industry's standard neutral benchmarking body. So for now, these performance claims come directly from Huawei's own announcements and Chinese language technical sources, not independently audited testing. It's worth explaining exactly why the manufacturing side of this story matters as much as the chip's raw specifications, because it's the part most headlines skip entirely. Nvidia's most advanced chips are manufactured by TSMC in Taiwan, using extreme ultraviolet lithography machines built almost exclusively by ASML, technology that lets manufacturers etch billions of transistors onto a chip with extraordinary precision in relatively few processing steps. SMIC, the Chinese foundry producing Huawei's Ascend chips, has been cut off from that EUV equipment entirely under export controls, forcing it to rely on older deep ultraviolet lithography instead, achieving similar transistor density only by running silicon wafers through multiple exposure passes, a process called multi-patterning. That workaround functions. The 950 PR is real, working silicon shipping to real customers, but it comes at a steep cost, slower production throughput, meaningfully lower manufacturing yields, meaning a higher percentage of chips coming off the line are defective and unusable, and higher per unit costs than Nvidia or TSMC face using newer equipment. Industry analysts tracking SMIC's manufacturing generation used for the 950 PR have noted that hitting the chip's Q1 2026 launch date on schedule was itself considered a meaningful credibility milestone for a foundry operating under such significant technical constraints. And it's a big part of why analysts gave the rest of Huawei's aggressive roadmap unusually high confidence, despite the company's sanctioned status. If you're the kind of person who wants the actual specs behind a headline instead of just the scary number, go ahead and hit that like button. Because we're about to get into exactly what separates the real breakthrough here from the marketing spin. Here's what makes this release genuinely more significant than simply another incremental spec bump, though, and it has less to do with raw compute numbers and everything to do with software. For years, one of Nvidia's most durable competitive advantages hasn't actually been its silicon, it's been CUDA, the software platform that essentially every major AI lab and researcher on Earth has built their tools and workflows around over the past nearly 2 decades. A faster chip that Chinese engineers can't easily program for is, in practical terms, far less threatening than a merely competitive chip that slots directly into existing workflows. Huawei's answer to that problem is a toolchain called CAN, and its latest iteration was specifically engineered to mimic CUDA's programming interface closely enough that developers can port existing AI workloads onto Ascend hardware with dramatically less rewriting than earlier generations required. According to reporting on the March announcement, this CUDA-compatible approach is a significant part of why the 950PR reportedly won favor almost immediately with major Chinese firms. ByteDance and Alibaba were both reported to have placed orders shortly after launch, joining Tencent and Baidu as customers already engaged with Huawei's broader Ascend lineup. That customer list matters enormously because it points to something beyond a single chip specifications. It suggests the beginning of an entire alternative AI hardware ecosystem taking shape specifically inside China, one built to function independently of Nvidia entirely, from the silicon all the way up through the software stack. And Huawei has been explicit that the 950PR is only the opening move in a much longer campaign. The company laid out a multi-year roadmap at its Huawei Connect conference back in September 2025, mapping a deliberate, aggressive cadence of releases, the 950PR, focused specifically on inference and recommendation workloads, arrived on schedule in the first quarter of 2026. A companion chip, the 950DT, optimized instead for training workloads using a different memory architecture Huawei calls HiZQ, is scheduled for the final quarter of 2026. Beyond that, the roadmap points to the Ascend 960 in 2027, which Huawei has explicitly targeted at reaching performance parity with Nvidia's current Blackwell architecture, followed by the Ascend 970 in 2028, aimed at matching Nvidia's next-generation Rubin platform. If that roadmap holds, and it's worth stressing that Chinese chip roadmaps have historically slipped before, industry analysts note it would represent Huawei closing a gap that stood at 5 years or more back in 2020 down to roughly 2 years by 2027, a genuinely dramatic compression of what had looked like an insurmountable technological lead just a few years earlier. There's also a system-level dimension to this story that matters just as much as any single chip's individual specifications. Because modern AI workloads increasingly depend less on one powerful processor and more on how thousands of processors are networked together to work in concert. Huawei has been pushing hard on exactly that front with something called the Atlas 950 SuperPOD, a system reportedly packing 8,192 Ascend NPUs into a single interconnected cluster, using Huawei's own high-speed interconnect fabric called Lingku. According to Huawei's own comparisons, that system claims roughly 6.5 times the aggregate computing power of Nvidia's competing NVL144 platform, along with dramatically higher interconnect bandwidth. Whether those brute force scaling claims translate into genuinely superior real-world performance depends enormously on the specific workload being run, and independent verification remains limited. But the architectural ambition itself signals that Huawei isn't simply trying to build a faster individual chip. It's trying to out-engineer Nvidia at the level of entire data center systems. If you're finding this kind of detailed breakdown of the actual engineering more useful than the clickbait headlines flying around this topic, that's exactly the kind of coverage this channel is built around. So if you haven't already, now's a good time to subscribe. The market reaction to all of this has been its own story, and it's worth understanding why Wall Street's response has been more nuanced than a simple sell-off in Nvidia stock. Despite the wave of headlines framing Huawei's chip as an existential threat, Nvidia's share price and business fundamentals have remained remarkably resilient. Through 2026, the company has continued reporting enormous data center revenue driven overwhelmingly by demand outside China, from hyperscale cloud providers across the United States, Europe, and the rest of Asia, building out AI infrastructure at a pace that shows no sign of slowing. Financial analysts covering the semiconductor sector have generally characterized the Huawei news as a meaningful long-term competitive signal worth tracking closely, rather than an immediate threat to Nvidia's current earnings. And since the vast majority of Nvidia's revenue comes from markets Huawei's export-restricted hardware simply cannot reach. That said, the psychological effect on investor sentiment has been real. Every incremental Huawei announcement now gets parsed carefully by analysts trying to model out how quickly China's domestic AI hardware ecosystem might eventually reduce its dependence on American chips altogether, even in scenarios where U.S. export policy toward China loosens further. Some coverage has framed this dynamic as a genuine grand bargain scenario, where a negotiated relaxation of chip export rules could actually work in Nvidia's favor by letting the company sell directly into China's massive and fast-growing AI market, before Huawei's domestic alternatives fully mature and lock up that demand on their own. Now, here's where it's genuinely important to pump the brakes before declaring Nvidia's dominance over, because the full picture is considerably more complicated than Huawei's press releases alone would suggest. A widely cited analysis from the Council on Foreign Relations estimated that even accounting for its most aggressive expansion plans, Huawei would produce only around 5% of Nvidia's total aggregate AI computing power globally in 2025. A share the same analysis projected would actually decline slightly to around 4% in 2026, even as headline-grabbing individual chip announcements like the 950PR continued rolling out. That's a crucial distinction. A single chip beating a single older Nvidia model on a specific benchmark is a very different claim from Huawei, meaningfully closing the overall computing capacity gap between the two companies at a global scale. Nvidia's advantage isn't just about any one generation of silicon, it's about manufacturing scale, an entrenched software ecosystem built over 2 decades, and a customer base spanning nearly every major AI lab and cloud provider. And Nvidia's own leadership has responded to this entire narrative with a posture that's notably more measured than outright panic. CEO Jensen Huang has repeatedly described Chinese AI hardware development as something the company takes seriously, without treating it as an existential threat, at one point characterizing China's competitive position in starkly close terms, saying the country was nanoseconds behind America in critical respects, a comment industry analysts have pointed to as evidence Huang sees real, closing competition rather than a distant, containable rival. At the same time, Nvidia's own business in China has been anything but stagnant. Following a significant U.S. policy shift in late 2025, the Trump administration replaced blanket bans on Nvidia's most advanced chips with a 25% export surcharge model, allowing full specification H200 chips back into vetted Chinese commercial buyers, with a quarter of that revenue flowing directly to the U.S. Treasury under what officials have described as a digital statecraft strategy. That policy reversal reportedly triggered a projected backlog exceeding 2 million H200 units for Nvidia in the 2026 fiscal year, a staggering figure that complicates any narrative in which Chinese buyers are simply abandoning Nvidia hardware wholesale in favor of homegrown alternatives. Huang has publicly pointed to China's AI market as worth an estimated $50 billion this year alone, with the potential to grow 50% annually, numbers that explain why Nvidia is fighting hard through policy and pricing to stay competitive inside China rather than conceding the market to Huawei by default. That regulatory backdrop has shifted more than once in just the past year, too, adding real volatility to how this competition actually plays out on the ground. In May 2026, the Commerce Department moved to close a loophole that may have allowed Nvidia's most advanced processors, including its newest Rubin and Blackwell chips alongside AMD's competing MI350X, to reach Chinese entities indirectly through overseas subsidiaries in places like Malaysia, despite broader restrictions meant to prevent exactly that kind of access. That kind of back and forth, restrictions tightening, then loosening through surcharge deals, then tightening again to close newly discovered loopholes, illustrates just how unsettled the actual policy environment underlying this entire competition remains, and how much both companies' fortunes in China continue to depend on decisions made in Washington as much as decisions made in their own engineering labs. There's also a broader competitive dynamic worth understanding, because Huawei isn't the only Chinese player reshaping this conversation. Chinese startup DeepSeek, which stunned the AI world in early 2025 with remarkably efficient, low-cost model releases, is reportedly now developing its own AI chip specifically for inference workloads, according to multiple sources familiar with the effort, a move that would reduce its own reliance on both Nvidia and Huawei hardware going forward. Around the same period, Chinese AI startup Jipu released a model called GLM that drew attention from prominent Silicon Valley voices. Tech investor Mark Andreessen reportedly described it as the first Chinese AI model many insiders felt could genuinely match and often beat leading American offerings, all while costing meaningfully less to run. Layer that alongside separate reporting, suggesting Zhipu's newer GLM model can match certain competing systems on cybersecurity benchmarks at a fraction of the cost, and a clearer picture starts to emerge. This isn't a single dramatic chip story in isolation. It's part of a broader, multi-front narrowing of the gap between Chinese and American AI capability, spanning hardware, software, and the underlying business economics of running these systems at scale. So, is Nvidia actually scared? The honest answer sits somewhere between the two competing headlines you've probably already seen. Nvidia is not losing its dominant position overnight, its manufacturing scale, its software ecosystem built over 20 years, and its enormous diversified global customer base outside China remain advantages that a handful of impressive chip announcements, however genuine, cannot erase in a single product cycle. But dismissing Huawei's progress as irrelevant would be its own mistake, because the trajectory matters here just as much as the current snapshot. A company that was supposed to be permanently crippled by 2019 sanctions is now shipping chips that major Chinese firms are actively buying, built on a roadmap, explicitly designed to reach parity with Nvidia's current architecture within roughly 2 years, rather than the 5 or more year gap that existed just a few years ago. Nvidia's own leadership acknowledging China is nanoseconds behind, rather than years behind. And the company's aggressive push to keep its own chips flowing into the Chinese market through a newly negotiated surcharge arrangement both suggest a company that's taking this competition seriously, even if scared isn't quite the right word for how a $4.8 trillion company with a backlog of millions of chip orders is actually behaving right now. What's genuinely changed is the shape of the conversation itself. A few years ago, the question was whether Chinese chip makers could survive under sweeping export restrictions at all. Today, the question is how quickly a company built specifically to route around those restrictions can close a technological gap that once looked permanent. That's a meaningfully different conversation, and it's exactly why this story is worth watching closely over the next 2 years. As Huawei's next chips, the 950DT, the 960, and eventually the 970, arrive on schedule or fall behind it. And as Washington continues adjusting the rules governing exactly how much of Nvidia's own hardware is allowed to compete on Chinese soil at all. What's genuinely changed is the shape of the conversation itself. A few years ago, the question was whether Chinese chip makers could survive under sweeping export restrictions at all. Today, the question is how quickly a company built specifically to route around those restrictions can close a technological gap that once looked permanent. That's a meaningfully different conversation, and it's exactly why this story is worth watching closely over the next 2 years, as Huawei's next chips, the 950DT, the 960, and eventually the 970, arrive on schedule or fall behind it. And as Washington continues adjusting the rules governing exactly how much of Nvidia's own hardware is allowed to compete on Chinese soil at all, there's also a longer historical pattern worth keeping in mind here, because this isn't the first time a dominant American technology company has faced a determined state-backed Chinese competitor working to close a seemingly unbridgeable gap. Telecommunications equipment, solar panel manufacturing, and electric vehicle production all followed broadly similar arcs. Years of Western companies holding a commanding technological lead, followed by a period where Chinese competitors were dismissed as merely cheaper but inferior alternatives, followed eventually by a genuine narrowing of the technology gap itself, not just the price gap, backed by sustained state investment and an enormous domestic market large enough to iterate and improve rapidly. Whether AI chips follow that same trajectory remains genuinely uncertain. Semiconductor manufacturing carries far higher technical barriers than solar panels or EV batteries ever did, and the EUV lithography choke point in particular has proven remarkably difficult for any country to independently replicate. But the pattern itself is exactly why serious industry analysts, rather than dismissing Huawei's progress outright, are treating it as a trajectory worth tracking closely rather than a one-time headline to shrug off. It's also worth remembering that this entire competition is unfolding against a backdrop where the definition of winning keeps shifting depending on who's describing it. For Nvidia, winning increasingly seems to mean staying so far ahead on cutting-edge performance and so deeply embedded in every AI lab's existing software workflows outside China that a domestic Chinese alternative becomes largely irrelevant to its global revenue regardless of how good it eventually gets inside China's borders. For Huawei, winning looks different. It doesn't necessarily require ever matching Nvidia's absolute best chip. It requires becoming reliably good enough, cheap enough, and available enough that Chinese firms no longer feel they have any real choice but to build their AI infrastructure around it, sanctions or no sanctions. Those are two different definitions of success running in parallel, And it's entirely possible for both companies to describe themselves as winning simultaneously over the next several years, without either one being wrong. If you want to keep track of exactly how this race unfolds, chip by chip, policy shift by policy shift, make sure you're subscribed, because this is one of the defining technology stories of the decade, and it's still very much being written. Thanks for watching, and I'll see you in the next one.